Hello dear student, welcome to Department of Chemistry. Myself Patil Jayashree. Today we study the flame emission spectroscopy. So what is the introductory part of flame emission spectroscopy? What is flame emission spectroscopy? The flame emission spectroscopy is nothing but the correlation of the emission intensity with the concentration of the element which form the basis of the flame emission spectroscopy. Generally, this technique is also called as the flame photometry. The substances which is not easily determined with the help of wet chemical methods, such a element or substances are determined with the help of this technique. For example, alkali and alkaline earth metals. This technique is very easy to operate because it required very small period, or it is having the highest sensitivity towards the substances, and therefore this technique is very useful. Also, this technique is mainly used in hospital to measure the level of sodium and potassium ion in the body fluids and tissue. Generally, in this particular technique we are using the flame method or flame test. Means the substance which is we are going to identify is introduced on the Bunsen burner flame, and from the characteristic color of the flame we can easily finding out the which element or which ion or which metal is present on our substances. For example, if sodium is present in our compound, then it gives the yellow color, light yellow color, which means that there is presence of sodium metal in our compound. Okay, so let us begin with the principle of FES, principle of flame emission spectroscopy. When the atom are excited, is emitted. When some particular atom get absorb some amount of energy, then it is get emitted some amount of light. For this, higher temperature is required. When atom are excited, light is emitted, and for this higher temperature is required. The temperature must be high. How much? It should evaporate the liquid component of the sample entering the flame in the form of mist or vaporize, and the residual solid particles into the gaseous state as completely as possible. Finally, after mist formation and vaporization, the gaseous state the solid compound is completely converted into gaseous state, and therefore the molecule get dissociate and they form a free neutral atom or radical. Mathematically, it is explained as h nu. H nu is equal to E2 minus E1. Here, the h is the Planck's constant, nu is the frequency of emitted light, E2 is the higher energy level, while E1 is the lower energy level. Higher energy level is nothing but the excited state, and lower energy level means the ground state. Now, you know very well that nu is equal to C upon lambda. C is the velocity of light, and lambda is the wavelength of light. If we put this value of nu in the equation number 1, we are getting the Sc divided by lambda is equal to E2 minus E1. Suppose we rearrange this particular equation, we are having lambda is equal to Sc divided by E2 minus E1. So by knowing the value of lambda, one can tell about the which element is present in our flame. This is the mathematical expression, and from the above diagram we can easily see that delta is nothing but the h nu, means amount of light is evaporated to convert the ground state into the excited state. Okay, so let us begin with the steps involved in the flame emission spectroscopy. This technique, this particular step we are already seen into the principle. What happened in this particular instrumentation? So the sample which is going to analyze is get spray on a hot flame. Then after introduced into the flame, they are converted into the mist, means formation of mist. Next is after mist formation, the particular compound is vaporized and they get converted into the solid particle. That solid particle get dissociate, and there is generation of a neutral atom. Finally, to set the atom in the excited state and the ground state. After neutral molecule get generated, they are stable into the excited state and ground state, and finally measurement of the wavelength and the intensity of the emitted radiation is carried out. This particular sixth step is very important while we are consider the instrumentation of flame emission spectroscopy. So in this particular technique we are using the Boltzmann equation. So Boltzmann equation is what? N divided by N star equal to AE raised to minus EA divided by KT, where N is nothing but the number of atoms remaining in the ground state, while N star is the number of excited atom, A is the constant for the particular element, EA is the activation energy, that is nothing but the difference in energy of the two level, K is the Boltzmann constant, and T is the temperature of the flame. Generally this equation is useful for the finding out the number of excited atoms, and generally this technique is depend on the temperature. As the temperature is increases, means if higher the temperature of the flame, the number of excited atom are also more. This technique is useful for calculating the number of excited atoms. So this Boltzmann equation is very important from the exam point of view. 1 marks question is generally asked on this particular topic. So let us begin with the advantages of FES. It is generally more accurate, and since the atomization into the flame is more reproducible method, and introducing the sample into the excitation method, means this technique is very accurate. Second is what? It is a very faster technique. Then third is it's having the much more sensitivity towards the detection of the alkali metal and alkaline earth metal. Next is, as number of lines are limited in the spectra, it is easier to resolve and identify individual member even in the presence of the other element, means it have a resolution type of spectra. Generally this technique is very easy to carry out and required not any staff. The preparation of the standard solution is much easier than the other spectroscopic method, therefore we are preferred the flame emission spectroscopy. So next is limitation of flame emission spectroscopy. Limited number of elements can be directly determined in the conventional flame. Next is the concentration of the element which are not determined in the conventional flame must be high. Third limitation of this technique is solid substance cannot be used directly, hence their preparation into the solution is must while we are applying in the flame emission spectroscopy. Instead of sharp line, we are getting the diffuse band of the compound, and this is due to calcium oxide or calcium hydroxide, copper oxide, means hydroxide and oxides, and they must be interfere into the line spectra of the spectral separation. So these are the different types of advantages and disadvantages or limitation of the flame emission spectroscopy. Let us begin with the instrumentation of the flame emission spectrophotometer. High temperature are necessary for the element which are not easily excited in the particular technique. The various steps are involved in the flame photometer are as follow. For example, for generation of the flame, we must be combined fuel and oxidant. After generation of the flame, in the flame we are introduced our sample. Then sample signal is transferred towards the monochromator. Monochromator select the wavelength of light and transfer towards the detector. Here we are using the photomultiplier tube as a detector, and finally detector detect their generate their data towards the amplifier, and amplifier gives the total manipulation and give the readout device in the form of graph or digital system. We are getting our result. The diagrammatic representation of single beam flame photometer is as follow. You can see in this particular diagram. See here, This is a fuel and oxidant that generate a flame. Okay, after that sample is introduced here and they give a result into the monochromator. Monochromator select the particular wavelength of light and gives to the photomultiplier tube. Photomultiplier give their signal towards the DC amplifier. Amplifier amplified that data and provide the information towards the recorder. What happened? Recorder give the information in the form of graph or in the form of digital reading. Okay, so student, in this particular case we are considering the 4-5 step for the instrumentation of the flame emission spectroscopy. So let us begin with the types of burner. Before starting the types of burner, we have to know the different type of steps that is involved in the single beam flame photometer. First is choice of gases. Various flame can be used for the flame photometer and they are generated with the help of different type of gaseous material. For example, air methane, air illuminating gas, air propane, oxygen propane, air gasoline or air acetylene. The choice of the particular fuel gases is generally depend on which element is to be determined. Next is what? The flame temperature. The temperature of the flame depend on the type of the gas mixture we selected. The mixing ratio is dependent on the different type of component. Excitation of the spectral line is depend on the temperature and we can easily find out with the help of Boltzmann equation, that is we are already seen in the previous topic. A hotter flame better vaporizes the sample and higher temperature promotes the dissociation of the non-emitting compound like alkali or alkaline earth metals. Next is gas regulation. In the quantitative flame photometer, reproducible and steady flame is generally required because they give a uniform result as the final. Means flow of the fuel gas and oxygen air in the flame must be kept as uniform as possible to get the reproducible result. Finally, the flow of rate of fuel and oxidant for a given sample, the instrument, both the intensity and the steadiness received the detector depend upon the flow rate of fuel and oxidant. In most of the instrument, these two are easily adjustable but has a certain limits. So introduction of the sample into the flame, the uniform feeding of the sample and standard into the region of the excitation is very important for the accuracy of the procedure. For flame analysis, the substance is generally dissolved in acid and then spray with the atomizer, the aerosol of the liquid droplet in the air and oxygen mixture with the gas. So the uniform feeding of the sample is most important while we are using the flame emission spectroscopy. Next is what? The burners. Which type of burner is useful for the generation of the flame? Here we are using the two types of burners in the analytical flame. First is the open burner, that is nothing but the Bunsen burner. But nowadays this type of burner are hardly used because they are having the easily flame flash back. Therefore we are using the maker's burner. Generally two types of maker burner we are using. First one is the total consumption burner and second one is the premix burner, or it may be called as the laminar flow burner. So we in this particular flame emission spectroscopy we are using the maker's burner. Maker's burner are how many? Two. First is premix burner and second one is the total consumption burner. How they can use, what is the advantages of the premix burner, also the total consumption burner. This topic we are already covered into the atomic absorption spectroscopy. So it is not necessary to repeat this particular topic again. Now we can see the series of events into the flame photometer. In the series of event we can consider the component into the flame photometer. So The component here used is first was lamp. Lamp is in which we are considered the mirror. A very small portion of radiation emitted by the flame enters into the flame photometer. In such a cases, gain in sensitivity. Generally here we are using the concave type of mirror. The concave mirror creates an inverted image on the flame of equal size at location of the flame. This might be expected to double the light intensity. So to increase the light intensity, we are using the concave type of mirror. And next is what? Slits. There are generally two type of slit are used here, entrance slit and exit slit. Entrance slit is placed in between the flame and optical system, while the exit slit is present in between the monochromator and detector. Here, the entrance slit is placed in between the flame and optical system. Here is the entrance slit, and the exit slit is placed in between the monochromator and detector. Here the detector use is photomultiplier tube. There are generally here we are using the monochromator. The term monochromator is useful to select the particular wavelength of light. The term monochromator is the name applied to the combination of monochromator. Consider two types of monochromator here, prism and grating monochromator, and the next is filter. Here the main principle of the monochromator is to select the particular wavelength of light. That selected wavelength of light is transferred towards the photomultiplier tube. Photomultiplier tube should be so placed that the beam of light emerging from the optical system covers the entire photosensitive area. If detector is too close to the exit aperture, only small region of the photosensitive layer will be utilized. If on the other hand, if detector is placed too far, some of the light will pass to the photosensitive surface. In good instrument, photodetector has to be correctly adjusted for the flame emission spectroscopy. The next is detector gives the data towards the amplifier, and finally we are getting the result in the form of readout device. So the instrumentation of the FES is multiple hollow cathode lamp is used here, then chopper, then flame, then introduction of the sample into the flame, finally monochromator. Then monochromator give the wavelength of light signal towards the detector give the information towards the amplifier, and finally the readout device gives the spectral information of the flame emission spectroscopy. This technique is very useful while finding out the alkali and alkaline earth element, or the element which is not easily determined by the wet method. The main difference between the atomic absorption spectroscopy and flame emission spectroscopy is that in atomic absorption spectroscopy we are consider the unexcited atom, while in the flame emission spectroscopy we are considering the excited state of atoms. Now let us begin with the interference into the flame photometry. In this particular session, we'll discuss the fundamental interference, and they are as follow. First one is the cross sensitivity interference. In this particular radiation, consisting of the unwanted transmission by the filter stray light in the monochromator, means what? They are having the unwanted spectral information by the monochromator. In other words, due to instrumental inadequacy, means proper instrumentation is not carried out here, and that causes the interference into the normal instrumentation. Next is what? Background interference. Background interference cannot be entirely eliminated by the instrument. It is always present at the wavelength of the analytical line or band. Next is spectral interference. It's caused by the two or more elements which have very close emission line, and this result in the wrong answer. Means if two elements which is having the very nearly result very nearly its wavelength of light, then they are interfering in the uh, normal spectral information. As I already told into the previous chapter, that is atomic absorption spectroscopy, if two wavelengths are same and we are required only one, the other element get interfere in it. Next is anion interference. Anion interfere as an component of salt or acid, and thus serious analytical error may be caused. For example, chloride causes a dissociation interference, and chlorine ion also affect the ionization through the formation of Cl ion into the flame. The other ions also play an important role here. For example, phosphate sulfate can cause the vaporization of the interference with alkali earth metal, and the formation of the non-volatile alkali earth phosphate or sulfate is present as an interference. And the last one is the cation interference can be decrease the signal intensity of the metal which is present into the sample. For example, here the interference of sodium and potassium is most of the case is occur. The intensity of the light emission from a given solution is affected by the presence of the salt, acids and organic substances. Therefore, the change in physical property of the solution such as viscosity, surface tension, density on account of the intensity of light is affected. Means to remove the interference, we should use the proper compound or purified form of compound. We should properly handle the instrumentation. So the last part of the FES is application of flame emission spectroscopy. The flame emission spectroscopy have the application. First one is the qualitative analysis. Qualitative analysis means what? Alkali and alkaline earth element can be easily detected by using this technique. It is comparatively a simple and fast technique. It is a reliable technique, but structural information of the compound present in the solution cannot be obtained from this technique. The element like carbon, hydrogen, halide, which are known as a non-radiating element, cannot be detected by this technique, but some special modification, the presence of this element can also be detected. Here we have to only consider the alkali and alkaline earth element is easily find out with the help of flame emission spectroscopy. Next application is quantitative analysis. Mainly the alkali and alkaline earth element are determined quantitatively. The concentration of the element in the sample can be determined quantitatively by using any one of the technique. For example, standard addition method, or second one is the internal standard method. Both the technique are useful for finding out the concentration of the element which is present into the sample. Generally, in standard addition method, we are using the series of standard solution, then unknown solution, and from the slope we can easily finding out the unknown element. Next is internal standard method. One is standard solution and other signal intensity of unknown sample solution is get recorded, and from the graph we can easily finding out the concentration of the unknown element into the solution. Next application is simultaneous multi-element analysis. To carry out such an analysis, different types of method generally useful. In one of the method, the Vidicon detector system is used, and the second method is silicon diode Vidicon detector system. So both these techniques are useful finding out the multi-element analysis. The next application of the flame emission spectroscopy is miscellaneous application. In miscellaneous application, there are so many applications. First one is the agriculture and botany. This technique was first applied to the agriculture and related field in the work of plant physiologists. It is useful in the determination of fertilization requirement of the soil. The plant are also subjected to routine analysis. For special ashing method are generally useful here. The element like sodium, potassium, iron, calcium, molybdenum or aluminium can be easily determined with this technique. The presence of test element and their concentration can also determine. Means to improve the soil fertility, we can use the different type of fertilizer, and from which type of fertilizer should be useful, we can easily find out this flame emission spectroscopy. Next is food and nutrition. Butter, milk are first ash before analysis. Means before application into the flame emission spectroscopy, the product like butter and milk are first converted into the ash, and then it can be used in the analysis. Otherwise, the solid material present may clog the atomizer. So but fresh milk and like can atomize directly because they are in the liquid state. Fruit juices, soft drink, alcoholic beverage should also ash get high precision, and from this we can easily determine the sodium, potassium, calcium, magnesium which is present into that particular food material. Next is, in the field of medicine and biology, FES play an important role in the determination of sodium, potassium, calcium in the body fluids, and this technique is similarly determine the other element also like magnesium, copper, and can also carried out within the flame emission spectroscopy. The last one is geology, industry, and other. The flame emission spectroscopy is useful in this particular field also. In this, natural and industrial waste water analysis can be easily carried out with this particular technique. In these cases, there is dilution, ashing are unnecessary. Usually, chlorine content is determined here. So, flame photometric technique can also be applied in the chemical industry and pharmacy. So, this technique is very much important from the different point of view, and it is very applicable in the quantitative analysis, qualitative analysis, in the agriculture field or food industry or medicinal industry. So due to this particular point, we complete our flame emission spectroscopy chapter. If do you have any question regarding this topic, you can ask into the discussion forum. Thank you.